Now we will look at the types of networks. When you look at computers, how they are connected through the internet, there are multiple types of networks like centralized, decentralized, and distributed that we can look at. Before looking at actual blockchains and understanding what this blockchain is all about and how it is different and how is it nearly an ideal solution as we saw earlier, we need to look at the types of networks first. There are three types of networks. If you go back to your college, you would have learned the types of networks like centralized network, distributed network, then comes decentralized network, etc. What are these networks? Let's first look at centralized network to understand what is this network all about and what are the advantages and disadvantages of these. In a centralized network, if you take any application in the world that you are using today, it is a centralized network. Take Facebook, Uber, Amazon, any of the networks, all your banks are central networks. Why do I call them as central networks? Because let's consider this particular node to be a person and it is a client for that particular service, bank or Facebook or anything, right? And this person wants to send, let's say, $1,000 to some other person in the network, in the same bank also. This request that I want to send $1,000 to someone else in the network goes to the central authority, right? This particular node, and this particular node does some validations. In a banking transaction, what are the kind of validations that you will look at? You look at if the KYC for the customer has been done. Is the customer, this person, does this customer have enough balance to send to the other person? It shouldn't be like he only has $500 and tries to send $1,000, right? So they will check that. They will also check if you're a terrorist, smuggler, your account has been frozen by the government and all of these other checks. Then once the checks are over, once the transaction has been validated, the amount goes to the other customer. And that's how centralized organizations work. There are two problems when it comes to centralized networks. The first one, as you can see here, is called single point of failure. What is a single point of failure? Suppose I was a hacker. Right? I want to hack this system, this centralized system. What do? I don't need to go to each and every node and hack any of these outer nodes. I have this beautiful package which contains all the data of all the customers in the network, and it is available to me like a piece of cake. I just want to hack this node to take control of the entire system. And that's single point of failure. Once this node fails, the entire network would definitely fail along with that. Okay, what is the single point of authority then? If you consider any centralized network, they have complete authority over the decisions that are made in the network. Take Facebook for example. The company called as Facebook or the service called as Facebook cannot be used by the people in China. They cannot use Google, they cannot use WhatsApp. Who decided that these people will not be able to use these services? Probably it's the Chinese government who put this restriction in place, but Mark Zuckerberg, who is the founder of Facebook, did not want to ask anyone. It's not a democratic kind of a situation, but he wants it. He can decide to switch off the servers of China just like that. And when that happens, this complete authority comes into picture. They have complete control over the network, right? If you know many of the chit funds, many of the smaller banks, they promise a lot of returns in terms of interest to the investors. So many people invested in that, and suddenly one day they decide to run away with the money, and they do it because there is a central authority and they decide everything. Even more simple example, if I want to give, let us take the example of Facebook itself, right? If Mark Zuckerberg wants to change the color of blue, which is predominant in Facebook now, to pink, does he ask you, hey Raghu, do you like pink color? I want to change it. No. He just decides and imposes the decision on us. That is authority which we do not want. Okay, how do you solve this problem? Is by going to the other types of networks. Let's talk about this distributed network. A distributed network, as you can see on the diagram, is multiple nodes connected to each other because they wanted to solve the problem of single point of failure. Hence, let's say you take the data and then you make multiple copies of it, right? Spread it across the world so that there are multiple copies of the same content in various parts of the world in various nodes. Now, if a hacker wants to confuse the network, take control of this network, even if he hacks one of the nodes here, it is not enough. He needs to get control of all of these nodes, or at least 50% plus of the nodes, because if he hacks this data and the other nodes are staying in okay, majority wins kind of a situation, right? The other nodes will come and say, okay, this is hacked. Immediately they'll get a copy from the other node and replace the data, right? That's how distributed networks solve single point of failure. They have multiple nodes which collectively execute a job. A good example of distributed network would be CDNs, something called as content delivery networks, right? They are placed in multiple parts of the world so that if you are a person accessing Facebook from India, you will be fed the data from a server in Mumbai, not something from US, because it takes time for data to be sent from US to India, and latency is there. So that is the advantage of using a distributed system where they focus on single point of failure, and that will be solved here. But still, we have this huge problem of single point of authority. Even though the distributed system has multiple nodes and multiple copies of data, all the nodes are controlled by a single authority, single entity, even though it is distributed. Now, to solve that problem comes decentralized systems, where multiple nodes are connected to each other just like a distributed system, but the ownership is not with a single person or a single entity. The ownership is split between multiple people. Probably you might not get it at this point in time, but if I give an example, you will get it clear. Let's talk about torrents. You would all have used torrents at some point in time or the other in your life to download movies, to download softwares, whatnots. Right? Who is the owner of torrents? Is there a company called as Torrent which serves all of your movies and files and everything? No. It is people who are guiding these torrents. This might be me, this might be you, this might be another person, this might be another person. If I share a file, right, if I have a movie file in my system and I want to share it with all of you, you will be able to download it directly from my system. It doesn't go to a central authority like Netflix or Amazon Prime or somewhere and then go to you. It goes directly from my system through the internet to your system, right? There's no controlling authority of this. That's the reason why the governments, even though, because torrents are, giving us piracy and all of these issues, right? So to stop that problem, governments have been trying really, really hard to stop this torrents network from happening, but they cannot, because there's no single authority to decide that we can stop. It's decided by people, it's decided by whoever is using torrents, and we are the owners of torrents, right? That is a beautiful example of a decentralized network where there is no ownership at a single point. The ownership is distributed to all the nodes that are there in the network. That's how we solve the problem of single point of authority. But you might ask me, okay, if there is a decision that has to be taken, who takes that? Right? That's when the concept of democracy comes into picture. Whenever you take a decentralized system and you want to do the same thing, let's say Facebook is a decentralized system and you want to change the color from blue to pink, okay, or red, whatever. Now, this will be proposed by a person. Let's say this person is proposing this, hey, I think red will look better in Facebook than blue and whatever, right? So this will go as a notification to all the people in the network. Everyone will receive a notification saying, hey, someone is proposing that we can change the color to red, what do you think? And everyone will vote for the decision. So when people vote for a decision and the decision goes on, that's when true democracy nearly comes in. When more than 50% of the people in the network vote, yes, I do think red will be better, the change will be implemented. Otherwise, it's not. Simple as that, right? So that is the difference between centralized, decentralized, and distributed systems. Remember, the only difference between a distributed system and a decentralized network comes with the form of ownership. Distributed networks is owned by one particular person or an entity or an organization, whereas a decentralized network is owned by the peers or nodes in the network itself. There's no single authority.